At this point, I'd like to introduce Mr. Don Gelosh. Don is the first director of systems engineering at WPI, and he is with WPI's corporate and professional education group. He began his duties just recently, January 30th, and is still commuting back and forth between here and Washington quite frequently. He's working closely with companies and organizations involved in the systems engineering field and with WPI's facility in the development of his systems engineering programs. Don has more than 36 years of systems engineering experience with the U.S. Air Force, government, industry, and academia. He comes to WPI from the Office of the Deputy Assistant Secretary of Defense for Systems Engineering at the Pentagon. And prior to that, he worked as a senior systems engineer at SAIC. And Don will be addressing the current trends in systems engineering. Don, thank you for having us.
Thank you. Well, thank you, Rick, for that introduction. And I have to say that we are very pleased to see everybody here tonight. So we have great presentations for you. We want to try to make the INCOSE meetings enjoyable and fun. Okay, so we get more people to come out to it and more people to enjoy it. So we're really happy to see everybody that's here tonight. I'm kind of the warm-up act for Mark Lefebvre, who we're going to introduce later. So some of what I have to say kind of leads into what he's going to do. And we'll try to get you guys just feeling comfortable and happy and everything. So it'll be a great show for Mark. So let me start out with a joke, if I can. Okay, I haven't tried this joke before, so you're my beta audience. Okay, it's always dangerous to try out a joke on a beta audience. But there is these three people from a program office, coming back from an early breakfast one morning. We had a lead system engineer, the lead software engineer, and the program manager. And they're walking along, and the lead system engineer happened to notice in a dumpster there was this lamp kind of sticking out a little bit. And he goes, "Hey, why is somebody wasting a lamp like that? I could probably take it home and use it." So he pulls it out and starts cleaning it off, and guess what? Right, a genie pops out of it, right? So the genie pops out and says, "Okay, I'm the genie. Thank you for saving me from this lamp. I've been in here 1,000 years, blah, blah, blah." He says, "I can grant you 3 wishes. But since there's 3 of you, I can grant you each 1 wish." So the lead system engineer goes, "Okay, wait, me first. Yeah, lead system engineer is always up front and bold and everything." So he says, "Okay, I want to be riding my Harley through the American Southwest with a motorcycle gang of beautiful women." So the genie says, "Done." System engineer disappears. Software engineer comes up and says, "You know what? I think I can top that. I want to be sailing my boat across the South Pacific with an all-girl crew, beautiful women on my crew." Genie says, "Done." He disappears. Program manager standing there kind of looking at where these guys were before. Of course, the program manager is a woman. So she looks at the genie and goes, "You know what, genie, for my wish, I want those 2 jerks back in the office by lunch." So the moral of the story is, careful what you wish for, right? So you think I played well in the beta test? I can use that again someplace? Okay, good.
Unless it's at a women's conference. Yeah.
Well, no, women kind of got the last laugh on this, right? Mm-hmm. Yeah, so they always do.
The sooner you realize that, the better you be.
Jeff Merritt, ladies and gentlemen, in the back here. What we're going to talk about tonight, what I'm going to talk about tonight is what I've seen over my trek through life being a system engineer, system engineering trends, and where are we going in the future, if you will. So basically what I did, I kind of went to the web, looked up some things, and found this thing from CNN Money about what are some of the leading companies working on now, okay, and looking towards the future projections, if you will. First one, anyone ever heard about this? Electronic eyeglasses? Pixel Optics is working on this. Anybody that wears progressives or bifocals? Of course, if you wear progressive, you don't want to tell anybody, right? Because that get rid of the bifocals. But the idea is that you can either tap the temple of the glasses or tilt your head down, and they change prescriptions. Okay, so you could have a great prescription to be able to see far and wide and stuff. Then we look down, they change to the near vision. So this has a lot of ramifications for things for eyewear and stuff. Transparent LCD. Have you heard about this one from Samsung? Anyone seen the latest Mission Impossible movie? I think it was like called Ghost Protocol. Remember the car? Okay, remember inside the windshield of the car, they were talking about doing the maps and things, and Tom Cruise is looking at it, and he just pushed all the information over to his passenger, said, "You find the route." Okay, transparent LCD. I mean, just phenomenal usage of these things. Glasses-free 3D TV. How many of you have a 3D TV at your house? Okay, you have to wear the glasses? What do they cost per pair?
140?
Yeah, so how many glasses do you have?
None.
So how the hell do you watch 3D TV?
Paid $5,000 for the television.
Do you sit there and blink your eyes one at a time?
You don't have to worry when you have Dora the Explorer on it.
Oh, okay. She's not 3D, right?
A couple more beers. Right?
So basically, there's a couple technologies here. I think the one technology is kind of like those little things you get in Cracker Jack's box. If you look at one way, it's something. You turn it the other way, it looks like something else. They kind of make up the screen like that. So when your left eye is looking at it, you see one thing. Your right eye is looking at it, you see the other thing. And sometimes they do it back and forth. I think that would give me a headache after a while. Yes.
Fujifilm is you deployed that in their 3D still camera and video camera.
Oh, is that right?
I've got one in the car. I can show it to you.
Oh, that's just phenomenal. White spaces, Wi-Fi. Okay. What the FCC is doing here is actually opening up the spaces between channels 1 through 51. Okay, VHF and UHF frequencies. Okay, because between the channels there's some open spaces. So why not allow this space to be used by Wi-Fi systems? And being at this lower frequency, the Wi-Fi can go further and through walls and opticals and things. Okay, so one thing I'm going to talk about is, bandwidth. Do we ever have enough bandwidth? Now, I don't think we ever will have enough bandwidth. Commercial spaceflight, Virgin Galactic. Of course, Richard Branson, right? By 2014, must be able to launch tourists into space. Okay, 200,000 a pop for coach. Okay, no peanuts. All right, I can only imagine what first class is going to be like. What, like 90 seconds or something they're talking about, or 90 minutes or something? There's like a full orbit. I think it's like 90 minutes. Can anybody afford to go on that flight? You saving up your money? Yeah, okay. 3D manufacturing, Oak Ridge Labs. Now this is really interesting because basically you're talking about manufacturing things one layer at a time. That just boggles my mind. I'm not sure how they can do that. Anybody have any ideas about that or have heard about this?
Well, they have the rapid prototyping devices now that you can buy. I think it's about $200. You can buy one for your home. It's about this big. Okay. And basically, it lays down some sort of synthetic material layer by layer, and if you can put in a CAD drawing of a small home or a bust of Lincoln or a small little device that you've designed, this little device for the home will layer it up and you'll pull it out. It's multicolored.
Wow.
It's totally what you've put in CAD.
Can you do $10 bills that way too?
Pardon?
Can you do $10 bills that way too?
Only 11.
What's that?
Only 11.
Only $11 bills. Okay. Crash-proof car, Volvo. Okay. Now you know Volvo is owned by Ford, right? But Volvo has, always talk about crash-proof everything. So through the use of radar and sonar and squawking out codes and GPS locations and velocities and so on and so forth, Volvo hopes to have cars that can actually tell where other cars are. So you're about to get into an accident. If you see an accident about to happen, what do? You panic, don't you? It's just a natural reflection. I mean, the adrenaline hits, you freeze, you don't know what to do, boom, you're in a crash. The car will do it for you. Okay? I have a car that has an OnStar system in it. And if I were to get into an accident and the airbags deploy, OnStar would tell where I'm located and what have you. But then I found out that when I get home at night, my wife knew exactly what bar I had stopped at along the way and how long I stayed there. And so I figured out she had tacked into the OnStar system on my car. It was tracking me. So now I only stop at bars that are within walking distances of church parking lots. Electric highway. With all these electric cars out there and places to plug in, I think WPI just put in an electric station, didn't they, up on campus? They're going to put these coils down through the road that emanate, electric and magnetic field As the car drives through them, it recharges its batteries. I think that's pretty phenomenal. I can't think of a joke for that, so give me a second. Lithium air battery for these cars. They're saying that this battery would be small enough that it can actually small enough and powerful enough, it can power a car to go 500 miles on one charge. Can you imagine that? I mean, that's a big limiting factor right now, right? I mean, if you live in D.C., you can barely get from your house out in the suburbs into D.C. on one charge. Then I hope you find a place to plug in before you run out of juice, right? Well, so of course some of the hybrid cars have gasoline and stuff so you can keep on going and everything. Programmable matter, Intel 2030. Did anybody ever see that the latest Knight Rider TV show was on like last year or year before last? The car itself could actually morph into things. Okay, it could change from a Trans Am to an old beat up car. It could change color and things. That's what we're talking about. You know, little microscopic pieces that actually can either change color or change shape or what have you. That's just phenomenal. I mean, you could be driving a Porsche along, and all of a sudden hit a bump and turns into a Yugo. Okay, it's just something you don't want to do, but it's possible. So I mean, and of course there's thousands of others. We just can't get all of them tonight. But I just want to give you an idea of what the future is going to hold. So what does that mean for system engineering? Okay, I looked at this and figured, okay, what are some things that are going to happen here in the future? I'm predicting that everything and everyone will be interconnected and interdependent somehow. Okay, now think about that for a second. Aren't we all kind of interconnected already? I mean, how many folks are on LinkedIn? I know we started up a whole new system engineering group on LinkedIn. We got like, what, 85 members now? Just in a couple of weeks, that many members. How many folks are on Facebook? How many folks are on Twitter? Or Twitter? What is it? I don't get on that thing. So what's it called? Twitter? It's Twitters. How many folks are Twitters? Okay, so I mean, you're interconnected. How many folks have cell phones? Okay, it's getting to the point where everybody's going to have something. They're going to be interconnected to somebody else and interdependent on somebody else. Now think about that. I mean, we're actually going to talk more about collaborative works and system engineering and things, but you're going to be interconnected. Data, okay, an extension of that, information, knowledge, and wisdom. Okay, managing that and representing that is going to become more complex and wicked. Okay, now a complex system means that you can't predict all the possible outcomes. All right, complicated means that it's really complicated and it's really it has a lot of moving parts and things, but you can kind of predict what it's going to do. Complex means you really can't predict, you really can't test for all the outcomes. Wicked is you can't even begin to start on it. Okay, the amount of data we're going to need, and then representing that data in terms of information, knowledge, and wisdom itself is going to be more and more complex and harder to deal with. Here's what I talked about earlier. We will always need more bandwidth than what's available. Okay, the FCC could open up all this, the spaces between the channels. Great, we're going to need more. Because what? Because of the data. We're going to need more data, more bandwidth. We need it faster and being interconnected. See how these are all starting to play together? Requirements for higher energy storage density, faster recharging rates is going to increase exponentially. We're seeing it now, okay? All the cell phones that you have, they've got some kind of battery in them, right? And you have to recharge them. You want to recharge them faster, but you want them to last longer. The cars, you want cars to be able to go a couple thousand miles on one charge. When you get home, you plug it in, 20 minutes later, it's charged up. Right? Just think about this. All the different mobile devices we have need more power. They also need smaller, more dense storage of that power in a way to get it recharged faster. How about this one? How many of you get paper user manuals anymore with things? It's almost a thing of the past, right? You get a CD, if you're lucky to get that. Okay, sometimes you have to go to the web to get it. I'm predicting that systems in the future, this stuff's going to have to be built in. Okay, if you're not going to be any user manuals anyway, they'll show you how to turn on maybe. There'll be an arrow that says turn on here. Okay, you push that button and it can tell if you're having trouble. And it'll come up and offer you help. Remember back when the little paperclip in Microsoft? How many of you turned that damn thing off? Yeah, I shot mine. It's, But it's going to get better. And as system engineers, we really need to start thinking about how do we build this stuff in so it's more intuitive to people so you can pick it up, use it, and figure it out without having to go to a second source for some kind of information. Emergent behaviors and resultant opportunities will increase. Okay, let me ask you guys, what's an emergent behavior? Unplanned, unexpected. Okay, the system's complex, remember? You can't predict what it's going to do. All of a sudden, a certain set of inputs occurs, and it does something. Like, oh, shit, I don't want to do that. Or like oh, it can do that. Okay? Look at the cell phones. I mean, the cell phones themselves, the interconnectivity is really what helped Facebook get off the ground, right? Could anybody 10 years ago really predicted that? Could you predict the kind of interconnection we have now? I'm looking at it as emergent behavior. So, the result opportunities are going to increase as well. Are we as system engineers prepared and poised to exploit those opportunities as they come up? This is one, going back to my DOD days, the budget's tight, the money's shrinking down. There's going to be less acquisition of new things, okay? More reuse of legacy systems, which in itself is a nightmare, trying to put old legacy stuff together with some new things, but more sustainment. How many of you are seeing that now? Or getting, yeah, exactly. More reuse, more sustainment, okay? But you still need engineers in sustainment. Because as you sustain things and things break, you have to come up with new ideas of how to repair it, how to replace it. Maybe you need a new part in there. How do you go back and get that designed? I'm trying to advance in my pointer. It's not working very well. And we can certainly argue about this for the next couple of hours. I'm thinking that in the future, probably right now as well, the top 5 system attributes, affordability, right? Can the market afford it? It's not just can a DoD afford it, can anybody afford to buy this thing? Okay, iPads are coming in about what, $500 a pop now, $600 for $800 for the really fancy ones. That's kind of the market, right? What if an iPad came out at $2,000? Could you buy it? No. Okay. Adaptability. Can these systems adapt to new things, new missions? New ways of using them, new requirements, if you will. Assurance. Will the thing work like you want it to work in the environment it's intended to work in? Resilience. Will this thing work after a catastrophic failure of some kind? Okay, so all of a sudden it just stops working or something happens internally. It goes bad. Can it recover from that? That's the resilience part of it. And of course, reliability. Reliability and assurance really go hand in hand. Okay, if it's not reliable, insurance is probably not going to work. Okay, but you could be reliable and still not work within the mission itself. Okay, that's why those two are important. So, one more slide before we get to Mark. We're going to look at now, what does this mean for system engineers in general? I mean, our system engineers really need to be able to better and more effectively manage risk and complexity, right? I mean, you have to do risk up front. You have to be able to understand complexity. Okay, so the system doesn't get out in front of you. Okay, so you can understand what's going on. You have to be able to quantify impacts, which I call risk and opportunities. Okay, kind of the bad and the good, if you will. Okay, to society in general. I mean, no longer can we have system engineers with their face down, on the design table. They really got to come up, look around, and say, how's my system going to affect society? Okay, what's it going to do out there? Okay, the iPhones, the iPads. I can bet you, Steve Jobs had an idea of how he was going to affect a society. And anything that we put out there, we really need to have an idea of how's it going to affect it, how can we quantify that, okay, in terms of risk and opportunities. How about this one? Ability to effectively and efficiently speak, write, and brief. You all heard the thing about the system engineer. How can you tell an introverted system engineer from an extroverted system engineer? The extroverted system engineer talks to your shoes. I'm losing the Mark. You have to help me out here.
Show the drum.
Yeah, there you go. We are really putting a lot of this information into our courses. We're trying to really create system engineer leaders. Our position is, if you're a system engineer, you're expected to be able to lead. So you have to be able to, speak, write, and brief effectively. Here's the other one. How many folks are seeing this happening right now? How you communicate is way more important than where you work. Right? Years ago, everybody had to come together to a facility and work together to get things done. Nowadays, I live down in Virginia. Okay, I still work with my team up here at WPI. And I'm sure with, Raytheon, Lockheed, Boeing, you're all over the place, right? It's going to get to the point that if you're, interconnected, interdependent, maybe you don't even need to go to a facility. You just kind of go to a portal, or someplace, or maybe in the far future you're all interconnected, something on your head. You just kind of walk around, sipping your coffee and talking to your team. Okay, it's coming, believe me. The ability to influence, defend, negotiate, facilitate, what are these? People skills, right? Okay, how many engineers straight out of college have people skills? Okay, how many of you engineers straight out of college had people skills? Raise your hand. Okay, there's one back there who said, oh, I did, okay. The rest of you is like,
How many can do it now?
what's that?
How many can do it now?
Yeah, how many can still do it now? Exactly. You've got to do this. I mean, whenever you're up against, cost and schedule in a program, you're trying to tell a program manager this ain't going to work or you're not doing it right technically, you have to be able to defend that. Okay? You just can't go in and talk to your shoes and do it because they'll just run over you and away you go. Ability to visualize, analyze, and describe the big picture. I mean, this kind of goes back into quantifying impacts in general. It's a big picture. You need to know how you're going to work and interface with other systems. There's a famous example in DoD. They had built this helicopter that fired these missiles, if you will. And the helicopter was sitting on the back of one of these cruise ships that had a helicopter pad. And it took off, and as it was coming up, hovering up off the ship, the missiles armed and fired. And fortunately, it wasn't like pointing towards the bow or the conn tower of the ship. It's pointing out to sea. What had happened was they hadn't figured out that when that helicopter was hovering up, it went through the main radar of the ship. And the first pass of the radar armed the system. The second pass fired the missiles. And they're like, how'd that happen? So like I said, thank goodness it wasn't pointing to the conn tower. People really need to understand, how is my system going to affect other systems in the area? What's going to happen? What's the big picture here? System engineers need to be able to analyze and predict how systems will interact and interoperate. You can't let complexity, get in the way. Okay, you really have to have an idea for the big picture, how things will interact, how they're going to interoperate. At least an idea, if you will. And the bottom line from all of this, okay, is leadership, ethics, okay, talking about society, what's morally right and wrong, what you have to do and can't do, and systems thinking are going to become the most critical skills. Now I'm saying this on top of general, technical engineering skills that you have to have, but system engineers now, and 21st century and system engineers, these are going to be the important key skills.